Okay, hi Year 11, it's Mrs Horton here. I'm going to do a video for you to help with the sheet, what's it called? Nomenclature in Organic Chemistry, I think. I had a request for a bit of help for tasks 2 onwards, so I'm not going to do the entire sheet, but I've just picked 2 from naming alkanes, naming alkenes and naming haloalkanes. Now the first thing to note is that actually there is a bit of an error on this sheet. So it gives you the formula presented like this. This is the structural formula. It then asks you to draw the structural formula and name it. Well, that's wrong because you've already been given the structural formula. What you need to give is the displayed formula. Okay, that's the one where you show all the bonds. All right, and then name it. So I'm just going to talk you through, just sort of do a bit of modelling. I apologise for the very basic nature of my videos. I'm sure other people are doing all sorts of wonderful things with Loom and various bits and bobs. I am in my daughter's room. Her desk is an absolute mess. It's got pen all over it. And I don't have a printer, so I'm just doing pen and paper. Anyway, let's have a look at this. So naming alkanes. We've been given this structural formula, and first thing to do is to note the length of our longest chain. So we have got in our main chain 1, 2, 3, 4 carbons. The fact that this is in brackets, that tells us that it is attached to that carbon. Okay, it's not in our main chain. So we're going to start off, well, I'm going to start off saying 1, 2, 3, 4. So I'm going to say 1, 2, 3, 4. This is an alkane, which means there's no double bonds. So I'm going to put in all the rest of the bonds that the carbons need, making sure everything's got 4 bonds, which it has. I'm going to have a look at each of the carbons, and this one's got 1, 2, 3 hydrogens, this one's got 2, this one has got 1 and a methyl group, okay, and then this one's got 3. So when we come to name it, 1, 2, 3, 4, it's going to be bute, there's no double bonds, so it's going to be ane, and on the second carbon here, carbon 1, 2, 3, 4, we've got a methyl group. Now we don't actually need to put the number in for reasons that will become clear a bit later on in the course, but that is therefore going to be methyl butane. Okay, right, now we're going to look at D. They don't have A, B, C, D on the sheet, but just for ease I've done that on here. So we've got here a carbon with 2 ethyl groups attached to it. Okay, so I'm going to start off by doing my chain of all the carbons that aren't in brackets. Okay, so 1, 2, 3, 1, 2, 3. And then I'm going to do, this is an alkane, I'm going to put all of my bonds in, and then I'm going to start adding groups. So this carbon has got 1 hydrogen attached to it, and it's got 2 ethyl groups, C2H5, C2H5. This carbon has 1 hydrogen attached to it and 1 methyl group, CH3. And this carbon has got 1 hydrogen attached to it and 2 methyl groups, CH3, CH3. Now, when you are naming these compounds, first thing you need to do is to identify your longest chain. So if we just come back to the previous example, I could give you another colour. Bear with me. Let's see what's in here. Right, so we've got that chain of carbons and we've got that chain of carbons. This chain is 4 long, that is 2 long, so our longest chain is 4 and therefore the stem of the chain is bute. Okay, now here actually what we've got is C2, 1, 2, 3, 4, 5, 6. So we've got a chain there. We've also got a chain here, 1, 2, 3. So I'm just going to put 6 there, 3 there, chain there, that's 2, chain there, that's 2. So that is our longest chain, making the stem of it hexane. Okay. Now, you might find it easier for nomenclature purposes if actually what you do, if I redraw this down here, am I still in shot? Yeah. C2H5, so 1, 2, 3, 4, 5, CH3, 6, and then do all the bonds. And actually, just realised that if we are, oh, hang on, am I making errors here? No. If we're doing the displayed formula, that actually would be wrong, because that doesn't show all the bonds. So that should look like that, if we're going to do displayed, okay? For ease sake, I'm going to not do that, basically. I'm going to do groups like this, but just so you know, displayed would mean that you do all the bonds. So we're going to do a bit of a kind of displayed structural hybrid, all right? So C2, H5, so CH3, C2, HH, so that's C2H5. So then we've got this carbon here, okay, which has a hydrogen attached to it. Oh, sorry, hang on. No, wait. C2H5. Sorry, my bad. C2H5. And then, yeah, right, so we've got C2H5. Then this carbon here, C2H5. So C, okay, C2H5. This carbon has a methyl group attached to it. Because of space, I'm just going to do it like that. This carbon has a methyl group attached to it, and a methyl group there, which is that. Okay, so we can now see that we've got this chain, 6. We've got this chain. Where are we? 1, 2, 3. This chain, 2. This chain, 2. This is our longest chain. Okay. Now, when we number our carbons, it's not that you always go left to right or right to left. Okay. You number the carbons at the end based on the functional groups that are attached. Okay. And our functional groups, which are basically your alkyl groups here, so methyl and ethyl, are closest to this end. Okay, so our CH3 group, our first kind of functional group if you like, is closest to that end, whereas this is kind of 2 carbons away from the end, if that makes sense. So that's going to be carbon 1, 2, 3, 4, 5 and 6, and that therefore is going to give us, we've got methyl groups and ethyl groups. Our methyl groups, there's 2 of them, so that's going to be dimethyl, and then on carbons 2 and 3. So 2, 3, dimethyl, 4, ethyl, hexane. Okay, right, let's look at naming alkenes. We're going to follow exactly the same process, but we need to chuck a double bond in. Sorry, I just having a sip of coffee. So let's look at our chain. We've got 1, 2, 3, 4. There's no groups attached to it, nothing in brackets or anything. So I'm just going to say 1, 2, 3, 4. I've got a double bond there, so I'm going to put that in there. And then I'm just going to make sure my carbons have got the right number of bonds. CH3, CH2, CH, double bond, CH2. Okay, so again, with the numbering, we're not going to go left to right. We're going to start with the carbon that has the functional group attached to it. And that is down here, making that carbon 1, 2, 3 and 4. So if I asked you to name that, hopefully based on GCSE, you could say, well, that's butene. There's 4 carbons and it's an alkene. Okay. However, as you learn more, you'll learn about isomers, and some of the transition work is on isomerism. If you have more than 3 carbons in your hydrocarbon chain, then it can give rise to something called isomers, okay? Isomers, and they are compounds that have the same atoms, okay, so the same molecular formula, same number of carbons, same number of hydrogens, but they are arranged differently. So this double bond is between carbon 1 and carbon 2, but you could have this, where the double bond is between carbon 2 and carbon 3. Okay, we've still got the same number of carbons, we've still got the same number of hydrogens, so the molecular formula is the same, but the position of the double bond is different. Okay, for that reason, and that will give rise to slightly different physical properties. So it's important that we indicate where that double bond is. So that would be therefore but 1. And that tells us that the double bond is on carbon 1. Okay, right, let's have a look at question C. So this time we've got, right, so these are in brackets, so I'm going to start with that. C, double bond, C, H, CH3, and this has got 2 methyl groups attached to it, CH3, CH3. And so looking at our longest chain, 1, 2, 3, 4 beats 1, 2. So our longest chain is 4, meaning it's going to be butene. But this time we have a functional group attached to a carbon, okay, and our double bond's in a different place. Now, in terms of numbering, doesn't really matter whether you come from this end or this end. That's going to, if you come from this end, that's carbon 2. If you come from this end, that's carbon 2. And so the position of the double bond isn't actually going to change. But anyway, 1, 2, 3, 4. We've got a methyl group on carbon 2. So that is going to be 2 methyl but 2 ene. Okay. Now you may note that I've been doing kind of dashes and commas and stuff. There is a particular way that you do that, where the dashes and the commas go isn't totally random, but you will not be penalised in the exam if you get those wrong. So I'm not going to go into any detail on that now. Okay, the final one is naming haloalkanes, and you will be less familiar with these as a homologous series than you are alkanes and alkenes, because we don't do them in any great detail at GCSE. The naming is really simple. Haloalkane will always, the name of the halogen will always be the prefix of the name of that compound, and it's just fluoro, chloro, bromo, iodo, etc. Okay, this is a really straightforward one. We've got 1, 2, 3, 4 carbons in our chain. That's not a carbon, it's a chlorine. I'm going to pop that there. Put in my hydrogens. There's no groups, there's nothing in any brackets or anything like that. So that quite simply is 1 chloro, 1, 2, 3, 4 butane. Why is that carbon 1 and not carbon 4? Well, this is our functional group, making that carbon 1, and then we're going to number that way. Okay. If the chlorine was here, so if that was a hydrogen and this was the chlorine, i.e. if we had an isomer, okay, all of the same atoms, same molecular formula, different position, okay, then that would be 2 chlorobutane. And it would be 2 chlorobutane and not 3 chlorobutane, because we would number from the end that it was closest to, which would be here. Okay, we wouldn't number from there, 1, 2, 3, we would number from here. Okay, last one then is the last one on the haloalkanes activity, and this time you have got more than one halogen present. Okay, so let's have a look. We've got these in brackets. We're going to start there. C, it's got 2 methyl groups attached. So C, CH3, and a fluorine. Then we've got a carbon which has got a hydrogen attached to it and a bromine attached to it. Then we've got a carbon with 2 hydrogens attached to it. Then we've got a carbon with 3 hydrogens attached to it. Okay, so our longest chain, we've got a couple of options here. We've got this one, or we've got this one. 1, 2, 3, 4, 5 obviously beats 2, so our longest chain is pent, and therefore we've got a methyl group, and we've also got a fluoro, and we've got a bromo. So what do we do now? Because we've got 2 halogens, so how are we going to name it? Which takes priority? Well, with the halogens, very simple. When you're naming, you just go alphabetically. Okay. So let's have a look. Which is going to be carbon 1, which is going to be carbon 2, 3, 4, etc. We're going to start numbering this time from this end, because our functional groups are closest to this end. Okay, making that carbon 1, 2, 3, 4, 5. Okay, right, so now we've got, where are we? Fluorine and bromine. So bromine, bromo, is obviously before fluorine in the alphabet. So we've got 3 fluoro, 3 bromo, 2, is that 2? Yeah, 2 fluoro, 2 methyl pentane. Okay, there's no double bonds there, so it's going to end in ane, and that's how you name your haloalkanes. I would recommend that you go and Google priority table, IUPAC priority table. Okay, it tells you all of the different functional groups that you'll come across throughout A level. It tells you where they are in relation to each other on that table. Indicates how you name a compound. It tells you what your priority compound is. So for compounds like this, where you've only got one functional group, it's easy. But when you get some more complex structures where you've got multiple functional groups, you need to know, well, I've got, you know, a carboxylic acid down here and an alcohol down here. What's the priority? What's my numbering going to be? And you need to know that priority table in order to assign the correct name. Okay, hope that helps. If you have any more questions, please do email your teachers. Bye.